Alright, this is Intermediate Lesson 9, Measurement, which basically is going to deal with the perimeter and areas of different shapes, like triangles, rectangles, circles, and composite shapes, which means combining those into bigger shapes. So let's first go over different things about a triangle. In a triangle, each side is called a base. And then, if you recall from geometry, an altitude is the segment in the triangle that goes from a vertex to the opposite side, forming a perpendicular. So in this case, H is a base. You could also draw a base, H is an altitude. You could also draw an altitude from this base, making a perpendicular. You could draw an altitude from this base, making a perpendicular. So when you find the area of a triangle, it's 1/2 the base times the height. Height is an altitude. So you could find the area by taking the length of this base times this height, or you could find the area by taking this base and this height, or you can find the area by taking this base and this height. The important thing is that you know that the base and the height means altitude, that they are perpendicular to each other. It has to be the case. So to find the area of a triangle, you take 1/2 times the base times the height. To find the perimeter, you add up the lengths of all the sides. It's true in any shape. Let's look at an example. What is the area of this triangle? Well, this is pretty simple. We have the base of 5. We have this perpendicular altitude to that of 4. So the area of this triangle is 1/2 base times the height. It's 1/2 of 5 times 4. Just a friendly reminder, when you're multiplying 3 or more numbers, you can multiply in any order that you want. I'm going to multiply 1/2 times a 4 first and get 2, and then 2 times 5 is 10. So the area of that figure is 10 square units. We don't know what units they are. It could be inches, could be feet, could be sheep herders, we don't know. Another example, a parking lot shaped like the triangle in the figure below is completely fenced in during a street fair. If x equals 25 feet, what is the total length in feet of the fence? So it's asking for perimeter. The perimeter is 2x plus 4x plus 5x, which is 11x, and then you're told that x is 25. So that means that the perimeter is going to be 275 feet. Boom. Number 3. In the figure below, segment AB is congruent to segment BC. When you're given information about the picture that's not in the picture, you need to put it in there. So to show that those are congruent, we're going to put the same number of dashes on those. Now, if you recall, this isn't relevant to this problem, but you wouldn't know that at this point. The isosceles triangle theorem that we learned in a previous lesson says if those are the same, then these base angles are the same. Sometimes that's extremely helpful. I'm just going to throw her in. Segment AC is 6. So this whole thing here is 6. Segment BD is 4. What is the perimeter of triangle ABC? Well, this is going to require some knowledge from isosceles triangles. In an isosceles triangle, which this big triangle is, anytime you have an altitude from the vertex angle, you know it's an altitude because it forms a 90-degree angle. That's also going to be an angle bisector. Cut this in half. It's also going to be a median, which means it cuts this side in half. Now, those are things that you should know and commit to memory. So what that means is this triangle that we see right here, just going to redraw it. 4. If this whole bottom side is 6, then that means each half of those have to be 3. So this is 3 here and 3 here. Well, without doing much work, this is a 3, 4, 5 right triangle. It's Pythagorean triple. If you don't remember that, use the Pythagorean theorem, and you would take 3 squared, which is 9, plus 4 squared, which is 16. Add those, you get 25. That means that the hypotenuse has to be the square root of 25, which is 5. So if we know that's 5, these two triangles are the same, that green triangle and this blue triangle, this is also 5. That's for the perimeter of ABC. So the perimeter of triangle ABC is 5 plus 5 plus 6, which of course is 16. Boom.